In this lesson, we're going to be looking more at slope of a line. We've already been discussing slope in class, but we're going to be getting into it a little bit more. We'll be learning on how to find the slope of a line when given 2 points, whether that be in a graph or just the 2 points, and we'll also be looking at finding slopes from tables. So you have your foldable, and then this would be the front of the foldable, and then you're going to open up the doors and see this stuff on the inside. One thing that you should notice about slope is that we use the letter M to stand for slope. So you'll see that being used, don't use the letter S, instead use the letter M. So we're going to first look at a graph and being able to find the slope from a graph. So let's open that door up and let's look at it a little bit closer. So slope is rise over run, or the change in y over the change in x. You'll also see it written change as a triangle, so you could see change in y over change in x. That's a Greek letter delta that means change. Another way for us to describe that change is y, when we're talking about y values, that is our vertical change. And then our x values are our horizontal change. Okay, so what that means when we are looking at a graph is that we are going to be looking at that vertical change, or how it's going up and down, and then the horizontal change is how it's going to be going left and right. So let me zoom in a little bit onto this first graph here. And the first thing that you want to do, if you are not given points highlighted, meaning that you can see like the dots on the points, you want to make a couple for yourself, and to know where those good points are, you want to see where it crosses that intersection, or where could you write an ordered pair. So here I have an ordered pair of -2, 1. Here I could write an ordered pair, but it would not be a nice whole number. So I can write ordered pairs on any points on this. I just want to look for nice whole number ordered pairs. So here would be another one as well, and then it keeps going in this fashion all throughout it, and it keeps repeating. Slope repeats over and over again. I only need to pick 2 of those points. So I'm going to erase some, and I'm just going to pick those 2 right there. And usually you do want to pick them as close together as possible so you don't have to worry about reducing, but I'm going to give you an example where they're a little spread out and we'll end up having to do some reducing in our fraction. Again, our slope is going to be the change in y over the change in x. So you're going to, when you read a graph, you also read it the same way that you read a sentence. You read it from left to right. I'm going to start at my leftmost point, and I'm going to rise up, and that will give me my top number. So in this case, I'm rising a +2. Now sometimes a rise, or the vertical change, could mean a fall, and that would be a negative value instead. So I have a +2 for my change in my y. And then I want to look at my change in my x, or again, this time I'm going positive because I'm going in the right direction and versus the left direction. So I start right here and I'm counting 1, 2, 3, 4 steps. It gets to that value, or that dot right there, that point that I want it to go to. So my slope is 2 over 4, which can be reduced to 1/2. Let's look at one more example of looking at our change in y and our change in x in a graph. So again, I'm going to highlight a couple points. Here I see one, and then I see another one right there. Again, maybe your 2 points that jumped out to you were a little different, and that's okay. Yours will just reduce, or you'll get the same exact reduced fraction as me right away. It's just 2 different points that jumped out to you. this time when I rise, when I read it from left to right, I'm going to be going downhill. So I'm going to rise, it's actually going to go down, and it goes down 1. So my slope, I would start writing it, m equals -1 over, and I'm going to go over, or I'm going to run how many? In this case, I go to the right 2. So +2. -1 over +2, that doesn't need to be reduced, but I'm just going to make it look a little nicer without those colors and that positive sign on the bottom. Down at the bottom, you'll just see a little reminder to check your slope. So a positive slope graph is always going to, as you're reading it from left to right, is always going to go start low and go up higher, so it's going to be increasing. And then a negative slope graph going left to right would be decreasing. You could think of it as climbing down a hill for decreasing or negative slope, and climbing up a hill if you are increasing. Let's move on to tables. So open up the door that says that you can find it from a table. Again, we're looking at the change in y over the change in x. Slope is just a ratio, which just means a fraction or division. If you notice on this one, this says f of x. That's just a fancy math way of saying y. So when I'm looking at my slope, again, I'm going to remember that the change in y goes on top of the fraction, the change in x goes on the bottom of the fraction. So I'm going to look at those tables first, and in this case, it goes from -2 to 4, so it's increasing by 6. And then this time it's increasing by 4, here it's increasing by 2, and here it's increasing by 6. So it's okay, at least right now we're not sure that it's changing by a different amount, because the x values may be changing by different amounts as well. Sometimes when you do tables, that value is going to be always increasing by the same thing. So let's look at the x side of the table, and we are increasing by 3, and then we are increasing by 2, and increasing by 1, and increasing by 3. Now when it's the same, you should have the same, so if it's the same on the y side, it should be the same on the x side, and you'll get the same ratio every single time. Since we do not have the same on each side, we have to check to make sure that our slope is consistent. So we want to take that change in the y, so I'm going to take that first number, 6, and divide it by that second number, or that first number over on the x side, 3. So 6 divided by 3, and I get a slope of 2. I want to repeat that for the next number, so I'm going to go 4 over 2. Does that also reduce to 2? Well, yes it does, and I need to keep going to make sure that that is consistent throughout my whole graph, or my whole table in this case. And then that last one is actually a repeat. I don't have to do that again since I've already done 6 over 3, and I know that that's 2. Since they are all the same, then that means my slope for that is 2. Now again, some of the times you're not going to have to do every single point because they're all going to be the same. Sometimes you will just have a couple that are different, so it just depends on the problem in the table that you are looking at. We have 2 more ways to find slope to go. Our next way is to look at ordered pairs, or 2 points. So you open up the door that says ordered pairs, and then let's look at an example with that. So you want to figure out what is the change in y over the change in x. When we were working on the table in that last one, I'm going to reflect back, we were finding the difference between these 2 points. In our heads, we just kind of counted how many from -2 to 4, and that gave us a value of 6. All we were doing was really subtracting 4 minus -2 to find that difference. So that's what that slope is doing right there, is that it is giving us that difference between there. And then my x values, x2 minus x1, Again, over on my x's over here, I was just looking to see what is that difference between those two numbers. If I were to look on a number line and count from -1 to +2, what would be the change there? So it looks kind of crazy, kind of scary, but it really isn't all that bad. And I'm actually going to have you guys just put it back into a mini table and find out your difference, or your change in your y over your change in your x that way. So let's look at this example down here on the bottom. And I'm going to, like I said, I'm going to make it back into a table. So here's my x, my y. I have a 2 and a -3, and then a 5 and a -6. When I'm finding my slope, I need to remember my change in my y goes first. So from -3 to -6, I am decreasing 3 more, so I'd have a -3 for my change in my y. Now my change in my x is going up from 2 to 5, and it's going up 3, so it has a x change of +3. When I reduce that, -3 divided by +3 is -1. So again, that formula looks really scary, but that's all that we're doing here, is we are finding the difference between these numbers and subtracting them. We're thinking of them visually on the number line, and what is the difference between them, what is the direction we would be going on a number line. Alright, our last way of finding slope is from an equation. And the equation that we are going to use is slope-intercept form. In slope-intercept form, it's y equals mx plus b. So the m and the b are going to change for every equation. The m we should be comfortable with, because we've talked about it a couple different times in this video, stands for slope. And hopefully we can figure out from the name slope-intercept form that the b is going to tell us an intercept. Specifically, it's going to tell us the y-intercept. Remember, we talked about the x and the y-intercept was where it crossed the axes. So in this case, it crosses the y-axis at that number. Let's look at a couple of the examples at the bottom, and we'll see how easy it is to find our slope when given an equation. I'm going to write that just because I took it away, y equals mx plus b right on top here. Again, highlighting, here is my m, or my slope. So when I'm looking at my equation here, I have y equals -2x plus 5. The number in front of the x, or that's called the coefficient in front of the x, that will always be your slope. So in this case, I have the number of -2, so my slope is -2. Now if you're looking at the next one, you should see that you have a 1/4 in front of the x. Your slope is 1/4. The last one might look a little tricky, but how many x's do we see there? You should be able to know that there is a 1 in front of there, or that you see 1x. There's your slope right there. M equals 1. On the back, you'll find your summary and your question. Make sure that you do both. In the first one, you're going to find the slope between the 2 points, so look back at the foldable for that. And then on the second one, you're going to find the slope in the table. Again, look back at the foldable for help on that.